Hello and welcome back to the lab. Today on the bench we have a pile of parts. This is going to be decidedly more modern than some of the stuff we've looked at in the past on this channel. I have done a couple of these before, but some circumstances have fallen into place and I need to whip up a machine for a customer. Somebody who's familiar with the channel asked if I would put together a lab computer for them. So in this video, we're going to talk about a computer for the lab and some of the stuff you're going to run into if you decide to custom build a computer. Regardless, there is a ton of computer building videos on YouTube, a lot of reviewers of modern parts. That is not what this video is. What this video is going to do is I'm going to assemble this PC and I'm going to ramble while I assemble this PC. So I'm going to talk about some part selection, why I picked the parts I did, why I engineered the computer this way. So if that's interesting, stick around. Also, if that is something you guys would like to see, but you'd also like to see it in real time, I am kicking around the idea of doing some live sessions in the lab. Let me know in the comments what you guys would think about that if you'd like to talk to me live. What I'm kind of looking at right now is I have some people asking me to build things that I've already shown in the channel in depth, but some other technicians have liked what I've built and asked if I would build some for them. One of them is like the Tantec IC tester, things like that, and they asked me if I'd assemble the board. So rather than just turn the camera on and solder the whole thing up, I'm kicking around the idea of possibly doing a live event and assembling that as the work that I have to do in the lab, but also hanging out with all of you guys. So if that's something you'd like me to do, leave me, hit up the comment section below. We'll see what we can make happen. God knows I got enough compute. I can take the channel live. That's not going to be a problem. So with that, let's get into getting this thing together. This is not going to be a Windows machine. This is actually going to be a Linux machine. So especially with some of the parts that were picked, this is way overkill for Linux, but it's going to run fast. So the case, pulling the case out of the box, we have an Asus Prime AP201 case in black. If you're brand new to building a computer from scratch, when you pull the case out, there will be a baggie of hardware that sticks with the case. That's going to be motherboard standoffs, some nuts and bolts and screws, and a couple of other things. Definitely make sure you know where this is. That comes with the case. Sometimes you'll get some hardware with the board, not always. So some of the design constraints on this was a focus on speed, but the lab that this is going into is very space constrained, so they wanted something small. So in terms of one of my tech scopes, this is rather small. It's about the same. Actually, it's a little bit bigger than a 7603, but 7854 is a little bit bigger than this, so not too bad. To get into here, side panels pop off sideways. If I can, there we go. They just pop off. And this one also in particular is going to somebody that does not care about anything RGB. So there is not going to be a ton of RGB and gaudy hardware in this box. It's more, this one is more function over form. But one of the things that I did like about this case is in the front we have USB 3.0, power button, audio jacks, and a USB-C. So this is going to be, these are nice front facing when he has this on the bench. The other thing is, in the back, the board has plenty of USB and things like that. So, but we're provisioned for USB 3 and USB-C. Also, this is one of the smallest cases nowadays that will take a full-size power supply. Now, where that goes is in the front. So, power supply is going to mount up here in this one. That's fine, I think. As in most modern computer cases, for whatever reason, they have removed the CD-ROM drives or the 5 1/4 bays out of the front of the cases. It makes it tough for me here in the lab because I still use quite a bit of 5 1/4 drives. As a matter of fact, both of the primary use computers have Bluetooth USB, or not Bluetooth, Blu-ray burners on them. And they're USB'd out. So I still do quite a bit with CDs, working on some of this older stuff. I even do some 16-bit OS stuff, and I got a laptop with Windows 2000 on it just for that. So, does this come out? Oh, the front comes off for ease of use and cleaning. Let's see. All right, these two screws and the hard drive cage is going to pop out. Okay, getting the power tools to get this apart, and I realized I said hard drive cage. This is the power supply cage. So you guys are getting me unfiltered. I don't know if that's a good thing or a bad thing, but we'll figure it out. It should pop up. Yep, looks good. Okay, our power supply is going to go in here. Okay, power supply on this one is going to be a main gear ignition 850 watt. It was a good convergence of price, wattage, and quality. I've used these in a couple of builds recently, and they've haven't given me any trouble. Nice solid supplies. In the old days, you were able to judge power supply by weight. There used to be a correlation between how heavy the supply was and how good a quality it was. But some people found out that was the judgment criteria. And I've even seen some computer power supplies have lead strapping in the bottom of them. Make them heavier. The general thought was the heavier the power supply was, the more heat sinking and things like that the inverters had on them, and the better the build quality. I'm not too worried about the heat coming out the top because it will flip around. Cool. I want the power supply sucking in cold air in the front, blowing it out the top, because we're going to have a radiator up top that's going to be venting the hot air up top. So that's how we're going to do thermal management in this one. In and up. Okay, next part we're going to work on is the motherboard. I have the static mat hooked up. So we are going to take anti-static precautions while dealing with some of this stuff. Some people may recognize that tag. We have a Intel motherboard by MSI. It's the Mortar Wi-Fi. Nowadays, if you don't buy a Wi-Fi board, you usually don't get Bluetooth built into the board. And Bluetooth was desired on this one. We got Wi-Fi antennas, SATA cables, M.2 drive standoffs, which we'll be using, M.2 drive screws, which we may or may not be using, some labels, and a manual. You will need the manual in a modern computer to figure out which RAM slots to use when they move the memory controllers from the board into the CPU, from being resident in either the North Bridge or the South Bridge, depending on the implementation. The processors started to get picky about which RAM slots the memory was in. The CPU we're going to put into this beast is going to be a Intel i5 14600K. The K CPUs are unlocked clocks, and this one does not come with a heatsink, which is fine because we have a water block for it. The 600s, you don't necessarily need water cooling for. It definitely helps them turbo a little bit more efficiently and reach their maximum potential, because what's holding the CPU back is thermal limit and power limit, or I should say power delivery. But 600s aren't too bad. You can still put one of these under air. The 900s, on the other hand, I would not recommend running those without some form of liquid cooling. So we have an M.2 slot here, an M.2 slot here. We're going to be using this one because it's heat sinked, which is fine. And so there's my marker on this particular socket, and my marker on the CPU is over here, which means our processor is going to orient that way. The writing's going to be up, so that's not always a given. depending on the board manufacturer. However, in this one, it is. These sockets are very sensitive to physical damage, so we want to be very gentle when dropping that into place. You can leave this on and pop it off when you close the frame. That one's always gotten me a little nervous because these do take a significant amount of force to close. That is seated correctly. So it's latched at this point, but I have to bend it all. Oh, the board's even making noises. So there's a significant amount of force holding that CPU down on that socket. I know some of the Threadripper CPUs from AMD, they even come with a torque wrench. And if you don't torque the CPU correctly, you'll get RAM errors and all kinds of other weirdness. They've started doing this, only giving you a quick start guide, not giving you the manual that comes with the motherboard. You got to go online for the manual. Doesn't help you when you're building your first computer. But they used to tell you where to put the RAM slots in these, but they don't anymore. So I have to go look up the board model, get the manual, look at the RAM section, figure out where the memory goes. Okay, in this case it is DIMM A2B2. You would think it would be A1B1, but it is A2B2, which are going to be these two spots furthest away from the CPU, which is fine. The memory is DDR5 Ripjaws. One of the ways you can tell the memory is DDR3 or DDR4, or I mean DDR4 or 5, is if you take a look at the pin layout. You'll notice on this one right here, the board gets thicker. DDR3 and under are cut straight across. So if you see any kind of where the board comes out towards the center, it's a good indicator it's DDR4 or 5. All right, for storage, we have a terabyte of Samsung 990 Pro M.2. Very nice hard drive, good storage. One thing about flash drives is I think they're wonderful. If you use them, fantastic. They are wildly fast, incredibly popular. But please, 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 please keep a backup of your data, especially if it's important. Flash drives have a really bad habit of grenading themselves with zero warning. In the old days, with the mechanical drives, you used to be able to tell. The PC would get really slow. The drive would make a lot of noise. There were some things that would preclude a mechanical when it was dying. The problem is flash drives don't do that. You can have a flash drive where you turn it off, take your laptop in, fire it back up, and all your data's gone. It has happened more times than I care to think about. Switching from power to manual. Pop these off. This is going to be our M.2 heatsink. Yes, we have our drive holding pin support and our socket itself. M.2 drives, for those that haven't seen it, are actually really tiny. So they're packing a lot of storage space into a package that's really small. It's also really fast. These sit directly on the PCI Express bus, very close to the processor. The processor can get incredibly high-speed data from the SSD, which makes just the overall response from the computer very, very rapid. You're going to have a thermal pad here, usually, and it's going to have a plastic cover. You do want to peel the plastic cover off of the thermal interface material so it does its job. It does its job and keeps the drive cool. Typically, the SSDs, you will not get what the package says in terms of throughput on them. That's usually a thermal problem with the drives. Pretty much every SSD thermal limits. It is only in incredibly ideal conditions where the numbers are, but they are still incredibly fast and wonderful drives. Okay, so there's no graphics card going in this computer, so we're going to have the open slots, which is fine. This computer is being provisioned for a graphics card in the future if necessary. One of the reasons why we went with an 800 watt power supply, and why we went to a board with these amount of slots. We also have some interface. One of the primary functions of this computer is going to be coding some Arduino stuff, compiling some code, and doing some medium lifting in terms of compute. It is now time to mount the board in the case. First thing we're going to do is 1, 2, 3, 4, 5, 6, 7. So we have 7 bolt holes that we need to do. It's the typical 3 pattern and 1. Some boards are 3, 3, and 3. This is not. This is a mini ATX board, not a micro, but a mini. And so we only have 7 screws. Now, this is where the board gets its ground reference from. That's why there's star patterns around each screw. So the standoffs are very important. They keep the bottom side of the board from shorting out to the case, but also allow ground to pass through so it can hit the standoffs, or so it can pick up a ground reference for the motherboard. So I need to get the case, and then we need to make sure the standoffs are in the correct place. All right, we have 1, 2, 3, 4, 5, 6, 7. The other one's kind of hard to see right where the tip of my finger is down here. So the standoffs are already in the correct place, so not too much to worry about. We set the board aside to make room on the bench, and the walking static bomb that is the lab cat is presently sleeping in front of the fire. Don't need to worry about her shorting anything out. So let's get the board in, and we'll go from there. Some boards you will need to put a back panel plate in. This board does not. It's integrated, so we can just toss the motherboard in, making sure not to rake the standoffs on the bottom of the PCB as we put it into the system. That will help it not short anything out or destroy anything. So this is going to come down in. Actually, there's a lot of room in this case. I actually kind of like this. This is a nice, tiny case. Threads, 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 threads. Just making sure I see threads in every hole because I don't want anything shorting out. Now, there are 2 main thread pitches in a PC. We have a coarse thread, typically used in hard drives and sometimes motherboard mounting, but definitely power supplies and hard drives. And we had a fine thread that was typically used in CD-ROMs in the past. I have seen motherboards switch to the fine thread screws, so you want to make sure you know which screws are in which standoff. They'll go in, but they may not come out. The metal's pretty soft. That gets metal shavings into the chassis and a couple of other things. In this one, we have fine thread screws, so we're going to be putting the motherboard in with these. All right, back to the hand tools for this part, because I don't want to crack anything. One of the worst things you can do is over-tighten some of these motherboard screws, and you hear a sickening crunch as the board cracks. Doesn't happen often, but it is very possible. After you build enough computers, you kind of get a feel as to what's tight enough, what's too loose. I have done this a few times. I missed counting. There's 1 extra screw, but fortunately there was a standoff where it should have been. So we should be good there. There's an there's an extra one down here by the cards. So this would be really easy to throw a couple more hard drives in if it's needed or anything like that. But the technician this is going to has some network storage that I helped set up for them. So his bulk file and his bulk project storage is on his network. So just that 1 terabyte drive is going to be plenty. It just needs to run applications. 1, 2, 3. 4, 5, 6, 7, 8. All right. Now, if I wasn't using this case, I may have just gotten in trouble. I do know I'm going to have full access to the back of the motherboard to mount the bracketing for the CPU cooler. So I knew we were going to be okay on this one, but that is something you're going to want to check. If I didn't have this cutout here, I'd have to get that bracketing on there before I mounted the board to the chassis. For the CPU cooler, we got a AIO water block. These are nice alternative to water cooling. I do not want to build a water loop for someone who cannot maintain it. So if you cannot build your own water loop, because they do need to be serviced, just like the radiator of a car, drained every once in a while, flushed out, cleaned out, things like that, watched for leaks. These are a great alternative. They're an all-in-one unit. They kind of work until they don't. But at that point, they're well past their fresh date, and it's time to refresh them anyway. I have had very good luck with Corsair in the past, so we went with them again for this build. This is a 240 millimeter radiator. These AIO units, they never need servicing. You never have to open them up. As they age, a little bit of the coolant sublimes through the rubber and evaporates into atmosphere, so they will get a little bit of air bubble in it. You may hear some liquid moving around, but they're also very quiet. So with thermal management and where this is going to be in a lab space, we are going for acoustics as much as performance. So we're doing an AIO. This is the bracketing and everything like that. This is what we have to sort through. All of this is going to be socket specific. So I have to figure out what needs to go where. I believe this is the Intel bracketing. Yep, Intel hardware, AMD hardware. I'm not sure what a TR4 is. Probably more AMD hardware, but we'll go with that. We're going to put this at the top of the case. It's going to be fine. We're not going to sandwich the fans on this one, so I can pre-install the fans before we put it in the case and get major problems, or before it gets out of hand, which is what we are going to do. Hardware bag for the AIO. What you need to be really careful for these AIOs is this pump assembly is kind of heavy. So as you're maneuvering the AIO, working on it, things like that, this is kind of flopping around on the hoses. You can't disconnect it because that'll poke a hole in the water loop. But I also want to do this outside the case so this isn't smacking the board and smacking around the computer while I'm working. Pretty high blade count fan design with some air diverters on the back. So if we look around the edge, we should find right here 2 arrows. Dang it, 2 arrows. Now what those 2 arrows do is the one that's pointing that way shows you the direction of the airflow. The one that's pointing that way shows you the direction of the fan rotation. So as our airflow is going this way through the fan, this is the bottom, this is the top, we want to push this through the radiator, so our mounting wants to be that way. Now when you do one of these AIOs, don't worry, you will have extra hardware. They give you more screws. They give you enough screws that you can pretty much do any combination you need, other than fan sandwich on both sides. I've run into problems sometimes with having enough long screws to do that. This is fine. I'm also doing this by hand so I can feel it as I'm putting the screws in. Just move this over here so I'm not walking around the camera for every screw. All right, so that's bolted down. I'm going to do the other one real quick, and then we'll get this in the case. So there are short screws that come with these two. That's for when you want to mount the top side of the radiator to the case so you don't punch through the radiator. You want to be really careful not to go with these, well, to the camera, vertical lines. The longer lines are the fluid channel, and you also don't want to bend up any of these fins. That's the surface area for the cooling. Anytime these fins get bent or anything like that, that'll be a degradation in performance, which would not be good. So let me get the other fan on, and we'll go from there. Okay, we have our fans installed. Back to the case. Okay, to get into the top side of the case, there's a lip here. You just pop this off, and here's where our radiator goes. Now, when mounting one of these radiators, the real important decision is hoses to the back, hoses to the front. On this particular build, I'm going to put hoses to the front because I have some clearance that I need to worry about over here, and I don't want the hoses to be kinked in front of this fan. So I'm going to put the hoses up, and I'm going to bring them in this way over the processor. I will still be able to have access to add memory in there and everything like that, so it won't be a problem. So our radiator, which we will install right now as soon as I find a short screw, is going to sit in like this. Right like so. Now I need about 12 hands. Everything will be fine once I get this one bolt in. And the first one is always fun. Backing the screws off a little bit because it can slide like so. So I want this all the way back as far as it'll go. And we have plenty of clearance for our fans. So this fan's going to push air in. The radiator is going to be pulling air up. The power supply is going to be blowing air up. And I'm going to put one fan on the bottom blowing up. So that's going to be our thermal management, is going to be in and up. Hot air wants to rise anyway, so there's no reason why we have to fight against Mother Nature. When you do a PC like this, it can make the top side of the computers kind of warm, especially my CAD computer set up this way. And when it's encoding videos for YouTube, you know it's working. Top of that case gets a bit toasty, which is totally fine. It's getting it away from my processor, which is the important part. Okay, there's our radiator in, all 8 bolts. Everything's nice and tight, nothing's moving. Everything's good to go. Got to be careful with this thing now when I'm moving around the case, because I essentially have a wrecking ball attached to the case. So if you flip it down too fast, this can fly, shear parts off boards. So you definitely want to be careful until we get this mounted to the board, which will be the next task. Okay, so in test fitting this bracket, this is where that goes, and these slide for the different bolt holes, which is fine, but we have some double back tape that's going to stick to this metal plate, and so we just line up the holes. Now what that's going to do is on the other side, it's going to expose screws for me to put the hardware in. Camera's not going to show it up very well, but we have screws in exposed from behind the bracketing. So what I need to do now is I need to figure out, these are labeled, which will be helpful. We need the Intel 1700 bolts. So here we go. Let's check. Sometimes these are different threads. They are not. They are symmetric, so that makes it relatively easy. I want to be really careful not to drag the bolts on the traces. So I'm going by feel. Okay. So these nuts, which have a Phillips screwdriver in the top, these are what we're going to hook the heatsink up. This is pre-laced with thermal pad. And the Corsair thermal pads are pretty good. And the CPU is not crazy, so we don't need anything too crazy in terms of thermal interface compound. Be nice if I could talk tonight. Holy cow. All right, we've got the hoses routed properly. They are on swivels, which makes it kind of easy, but we want to make sure the logo on the box is right side up and the hoses are coming off the right side, which they are. So now we just set this on top. And then just get these started by hand. Of course, it's gonna be difficult. Okay, now that they're started by hand, just like a tire, star pattern, and just walk it down. You do not want to put too much pressure, side load pressure, on the CPU or the CPU socket. It is very rare, but I have seen and dealt with computers where the socket was, or the CPU was cracked because too much side load pressure got put on it. Now I don't necessarily need to worry about the back of the board because that bracket structure that we put on the back is what's holding the heatsink. So it's just, you don't want to crank these down. It's just kind of till they bottom out and stop moving, like right about there. So the wings are bent down a little bit, just putting pressure evenly on the CPU, which is exactly what we want. Now we have to hook up this bundle of wire. So this is going to be power and fan control, actually, yes. So we have a USB-C connection here, which is going to go in the back of the block. Like so. Now we're going to take this and we're going to dive it behind so we can wire up all the stuff behind the board, make it look nice. Okay, we're on the back side of the tower, and we're going to pull these off right here because we're going to have to start doing some cable management a little bit. Here's my power cable coming from the back of the computer. Given the weird location of the power supply, that goes right there for some strange reason, but that's all right. So we have our USB-C connection, which is going to need to pop out down here. We have our front panel controls, which are also going to have to pop out down at the bottom. We have audio, which is going to have to pop out down here. And we have USB-C, USB 3, which is going to have to pop out up here. And that's all my front panel controls. So I will not bore you guys with hooking all that stuff up. I will just get this rat's nest hooked up, and then I'll show you where it all goes. Okay, here's a tour of the front side of the computer case. I'm not sure how well the camera's going to show it up, but we have USB for the AIO pump, which is fine. It's into one of the headers. I have another one which is going to go unused. We have front panel down here, power LED, power switch. Worst part about building a computer is hooking up the front panel connector. It can be a pain in the butt. This is the USB 3. This is the USB-C. The USB-C cable you have to actually be very careful with. It's a very high-speed cable. Kinking this, pinching this, things like that, you can degrade the performance of the USB-C cable. So you do not want to fold this up. I know a lot of people like really neat wire computers, things like that, but you have to be really careful on the bend radius of the USB-C cable. The USB 3 cable, they make them stout enough. The bend radius kind of doesn't matter because you can't really bend them that far. HD audio's over here. We have hooked up the back panel fan to the CPU fan, which is hiding up here. And we have the pump AIO into fan 1. Now, that's going to help the BIOS not have a panic attack when we first turn the computer on because it's going to think the CPU fan's not running. We really don't have a CPU fan. It is a water-cooled unit. These two fans up here are controlled by the pump itself and the software of the pump. So what we're going to end up doing is once we get the OS on there, we'll install IQ. That'll give us control over the LEDs of this, which is kind of some people like RGB, some people don't. But it's also going to give us control of the fan speed and the pump. The way I used to like to run these, just in case, is I like to run the pump full out, which is circulating the water as fast as possible, and the fans at a, I turn the fan curves a little more aggressive. I like my chips cool, but I also am sensitive to the acoustics. So I don't run the fans full out all the time, but I also don't let them idle and be lazy either. So it's kind of a balance. As I hook in some of these modular power cords, for those that have dealt with a modular power supply before, may or may not know this, the cord manufacturers do actually key the power cords. They're not interchangeable. A lot of people went to the modular power supplies. I think that I don't think they're a bad idea. They definitely get the cables out of the case you're not going to use, especially in a build like this where we're not going to have, where I only need one peripheral cable for the pump and possibly a SSD in the future. But the modular power cables from different brands are not interchangeable. I have set hard drives on fire experimenting with it. Fortunately, it was not important hard drives that had important data on them. So just know that. And when you're building one of these, keep the power cables in brand-specific sorting because they are not pin compatible. All right, here's all the power supply, all the cabling pre-cleanup. We have the CPU cables installed. I have the motherboard cable running out into the chassis. I did remove the power supply. It made it easier to get in here. So this computer is now ready for its first power up. So if I did my job correctly, we should see no smoke. All right, we're going to take a look at it from the computer side, and then we'll take a look down at the test monitor below the bench. So first power on is now. We're booting. Diagnostic LED is here, which you can't see behind the hoses. It's yellow. Should go white if everything is happy. We at least had 12 volts start. See what happens. It's still thinking. Diagnostic lights out. There we go. It went white. And we have video. I will move you down to the monitor. Pardon the dust on the monitor. We had CPU changed, and it's going to pop up. It's rebooting. That's kind of normal for a first cycle. It's trying to figure out, the BIOS is trying to figure out what hardware it's got because it's lost its mind, or it never had a mind because it's a brand new build. So we have our CPU, 3.5. We are running the XMP profile, which is good. Memory is, we do see all 32 gigs of RAM. So this is actually set. Everything is good, and we are running the XMP. Not turning on XMP can leave a significant amount of performance on the table, but it can also cause some system stability sometimes. Everything's gotten a lot better from when you had to set all these timings and everything by hand. So, storage. It does see my drive. Fan info. Looks good. What I do need to do is I need to make sure it's in ACE. Storage is in AHCI. We don't want it in RAID mode. If you use an SSD with RAID that is not designed to support SSDs, it can actually drastically shorten the life of the SSD. So, with this PC is built and ready to go. I'm going to get Linux installed on it, but that's just boring software stuff. If you guys would like to see me install some software, let me know, and we'll do a separate video on OS installations. At the moment, everything looks good, but I'm going to call this video a success. So, if you have any questions or comments, leave them in the description below. As always, I will see everybody in the comments section between videos. Patreons run about 3 weeks ahead of the main YouTube channel, so if you're interested in seeing a little bit more content from me really quickly, take a look at the Patreon page. That may move forward a little bit quicker, given that I have a couple of backlogs of videos that need to be edited. And let me know if you'd like to see anything. So this channel exists for you guys, and I thank you all for being here. With that, I will see everybody in the next one.